Postulate 5 here is when you have 2 points, there exists exactly one line within them. This is important. You cannot have one line like this, otherwise it doesn't go through that second point. There has to be exactly one line. Postulate 6 is a line contains at least 2 points. This is about the opposite of that. You have a line here, you can draw at least 2 points on here. Postulate 7 is if 2 lines intersect, then their intersection will be 1 point, as you can see. Postulate 8 is through any 3 non-collinear points there exists exactly one plane. So it's like 1 point here, 1 point here, 1 point here. 3 non-collinear points, there exists exactly one plane within those points. Postulate 9 is a plane contains at least 3 non-collinear points. So again, like the opposite of that, you have Now I'm going to introduce you into our favorite subject, proof. Reasoning using properties from algebra. Let's look more into that. Okay, let A, B, and C be all real numbers. In the addition property, if A equals B, then A plus C equals B plus C. Subtraction property, if A equals B, then A minus C equals B minus C. Simple, right? Multiplication property. If A equals B, then AC equals BC. Division property. If A equals B and C is not 0, then A divided by C equals B divided by C. Substitution property is if A equals B, then it can be substituted for B in any equation or expression. So like you have A plus 2 equals 4, let's say. And A equals B, then it could be reasoned B plus 2 equals 4. A proof is a logical statement that shows a statement is true. There are several formats for proof. A 2-column proof has numbered statements and corresponding reasons that show an argument in logical order. So it's like a table. One on this side shows your work or statements, and the other side shows your reason for those statements. In a 2-column proof, each statement on the left-hand column either gives information or the result of applying a known property or fact to the statement already made, like I said. Each reason on the right-hand column is the explanation for the corresponding statement. Reasons used in a proof can include definitions, properties, postulates, or even theorems. A theorem is a statement that can be proven, remember? Once you have proven a theorem, you can use a theorem as a reason in other proofs. Let's prove angle-pair relationship 2.7. Theorem 2.3 is right-angle congruence theorem. You're going to use this a lot in proofs. It is all angles are congruent. All right angles are congruent. This theorem will reduce the number of steps in order to prove a right angle. You can prove this, actually. Theorem 2.4 is congruent supplements theorem. If 2 angles are supplementary to the same angle, or to congruent angles, then they are congruent. If angle 1 and angle 2 are supplementary, angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3, as you can see. Theorem 2.5 is congruent complements theorem. Two angles are complementary to the same angle or to congruent angles, then they are congruent. Like if angle 4 and angle 5 are complementary, and angle 6 and angle 5 are complementary, then angle 4 and angle 6 are equivalent or congruent. Intersecting lines. When two lines intersect, pairs of vertical lines in linear pairs are formed. The relationship that you have used for linear pairs is formally stated below as a linear pair postulate. This postulate is used in the proof of vertical angle congruence theorem. Postulate 12, linear pair postulate. If two angles form a linear pair, then they are supplementary. Like angle 1 and angle 2 form a linear pair, so angle 1 and angle 2 are supplementary, and measure of angle 1 plus measure of angle 2 equals 180 degrees. Theorem 2.6 states vertical angles are congruent by vertical angle congruence theorem, as simple as it seems. Identify pairs of lines and angles. Two lines that do not intersect are either parallel lines or skew lines. Two lines are parallel if they do not intersect and are coplanar. Two lines are skew lines if they do not intersect and are not coplanar. Also, two planes that do not intersect are parallel planes. Parallel triangle are shown in diagram parallel, like this, is shown on the problem. Let's look more into that. You can see what I'm talking about now. In the diagram, it is shown as either a arrow here or a triangle, usually red. And in the problem, it is shown as two diagonal lines that do not intersect, like that. Postulate 13 says, if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. This is confusing, I know. What it's saying is that if you have a point here and a line here, then there is exactly one line parallel to this line through that point. Postulate 14 is still difficult. If there's a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. Whoa. Okay. So what this is saying is that if you have a line here and a point here, there's exactly one line that goes through the point that is perpendicular to this line. We're going to go over now angles formed by transversals, 3.2. For time speaking, I just abbreviated them. Corresponding angles are angles that are cut by a transversal, and let's say angle 2 and angle 6. These are corresponding angles. That means that they are right of the transversal and they equal. They are congruent. Alternate interior angles are when you have two lines cut by a transversal and they are, alternating interior from each other. And these two angles are congruent. Alternating exterior angles is pretty much the same idea, but in exterior. And these can be here, here, anywhere on the outside here. And these as well are congruent. Now, consecutive interior angles are a little bit different than those. There again, two lines cut by a transversal, but these are on the same side as each other. Now this can pose a difficulty, and they lie between the two lines on the same side of the transversal. These will not equal each other. They instead equal 180 degrees. Angles formed by transversals, 3.2. This is corresponding angles are angles when you have two lines cut by transversal and are right of the transversal, like angle 2 and angle 6. Those are corresponding angles. Alternating interior angles are about the same, two lines cut by a transversal, but instead are alternating from each other, like angle 5 and angle 4 are alternating interior angles. You have two lines here cut by a transversal. Alternating exterior angles are the same thing as alternating interior angles, except they're on the outside. Hey, names. That would be like 1 and 6 or 5 and 4. Then consecutive interior angles are when they have two lines here cut by transversal and are on the same side on the interior. So like 3 and 5 here, angle 3 and angle 5 would be consecutive interior angles.